This is not a video on moon-based technology or moon-based concepts, as there are many videos and lots of resources covering that topic. I would also like to distinguish between a moon base as an outpost and a moon base as the foundations of a lunar colony. What we are focused on today is how a lunar colony will emerge from a lunar research outpost and evolve eventually into a lunar city. We'll look at the stages of evolution and discuss what the most important aspects of each are, as well as what needs to happen to make this a possibility, and what has already been done. First, I want to distinguish between the characteristics of a research outpost and a moon base. The terms are entirely interchangeable. However, for the purposes of our exploration, we will define the two. A research outpost will come first and is similar to other research outposts such as those in Antarctica. The International Space Station can be considered a research outpost. These are outposts that are typically in very remote and inhospitable places where, as the name implies, research is conducted. This is usually by a small team of highly trained experts who will remain in these locations for a number of weeks, months, or even years to conduct experiments and explore the environment around them. Research outposts are small, resource-dependent, and economically unsustainable. What I mean by this is that they depend on almost all of the basic necessities such as food and water to be imported, and while the discoveries or research conducted may have significant economic impact, the outposts themselves do not have any economy or private sector. Research outposts are usually state-sponsored and funded, restricted, and do not necessarily have emergent growth like a colony. You cannot move to the International Space Station or set up shop in an Arctic outpost. A base can be considered to be the foundation of what will become a colony. It is the base of the structure that will grow and expand into something bigger. Economies are the engines of expansion. A base has economic activity, or at least the potential for economic activity. An Antarctic base may conduct research as well as host tourists. It is common for old research outposts to be converted into bases. However, thus far, the only real economic activity Antarctica has to offer is just that, tourism. The moon, on the other hand, has great economic potential, as we will see later on. A base is still import reliant for basically every necessity, but may begin sourcing some necessities in situ, such as Antarctic greenhouses or water purification systems on the International Space Station, although both still import food and water. This is supplemental in nature, not sustainable, but it serves as a good foundation towards sustainability as it shows what is and is not possible in the given environment. Bases are less restrictive and may allow tourists or others to visit, as mentioned before, and because of this, they may generate private interest or funding, in return for feeding and sheltering the private companies, tourists, or whatnot. This is where we see the basis of a lunar economy. Space tourism is already taking off, and companies are flocking to the private launch vehicle industry. Billionaires around the world are already lining up and scheduling lunar flybys with companies like SpaceX and Blue Origin. But what comes next? NASA plans to return to the moon by 2024, and a permanent lunar research outpost is projected for sometime in the early 2030s, and other national governments have similar plans. How does one go about convincing a national government to allow private interests to arrange tours of their very expensive and classified lunar outposts? Luckily, the answer is, we probably won't have to. Governments are notoriously inefficient and slow at the DMV and in space. They are great at opening the doors to future markets, but once the private sector gets involved, the rate of advancement should no longer be measured in terms of how fast the government is doing something. This is evident more in the aerospace industry than anywhere else, and the US practice of passing the torch from government to private industry is where a lot of our successes have come from. In all likelihood, a moon base will be constructed by a private company like SpaceX before the 2030 timeframe proposed by NASA. The rapid construction of Starship is evident to this, driving down launch costs to never before imagined levels. If Starship truly costs $10 a kilogram to low Earth orbit, as Musk has stated, then launch cost will have fallen 99.9% since the year 2000, and Blue Origin, while behind, is similarly making great strides in its development of reusable heavy launch vehicles. The demand for tourism is already here, and the technology close behind. And while there are still concerns about safety that need to be addressed, I would argue that it will be a private company that establishes the first lunar base, not NASA or another state agency, and that they will do it sooner rather than later. But where is the best place to establish a lunar base? Some places on the lunar poles could be beneficial in that they receive year-round sunlight, allowing for a reduction in energy storage systems and solar panel imports. There is also evidence for water in these areas, frozen in the pits of craters that never see light. The poles are fine for scientific research purposes, but any permanent lunar economy will develop on the back of tourism at first. The Apollo sites, especially Apollo 11, is the best site to establish an actual settlement that plans to grow and evolve, as tourism would be propped up by the ability to view the original landing site. This would benefit enormously from having the ability to generate electricity even during the long lunar nights, which solar power is unfortunately unable to do. Nuclear generators are one option, but they present issues of their own, largely in their complexity and low output. But this is an important aspect, the foundations of growth, tourism. We see the significance of this in developing countries around the world where tourism builds the service sector that drives the development of the infrastructure that allows more complex economic sectors to emerge. Lunar tourism is nearly a given, and with it, assuming all goes according to plan, we now have a lunar base, with economic potential driving the development of technology and infrastructure in order to expand to meet the growing demand for lunar tourism. After the first base is established, competition will be close behind. A service sector will emerge, first as tour guides, and later as providers of goods such as souvenir shops offering 3D printed trinkets to tourists. #Made on the Moon. Mugs, desk toys, fidget spinners, t-shirts, anything that can be 3D printed will, for a time, be coveted as novelty. Also, even moon rocks and lunar regolith could be exported. Wouldn't you buy a lunar rock paperweight or a moon mug? Zero to low gravity 3D printing is already well established, and this printer by Made in Space is currently used to 3D print tools for astronauts on the International Space Station, so they can save money on launching replacement tools, as every gram counts. As the service economy grows, so too will the demand for expansion. New shelter units, greater comfort. People may even begin living permanently on the moon. Repairs to suits, tools, and other items will be needed, as new supplies will only arrive once every so often and will be more expensive given the cost of launching to the moon, even if launch costs are extremely low. This will see the emergence of people specializing in repairing EVA suits, people specializing in repairing and maintaining 3D printers, specializing in tour guides, specializing in overseeing new shelter construction, specializing in repairing the tires of the lunar rovers used to transport tourists and workers alike, etc. All of this will be done under the umbrella of the parent company that establishes this base, very similar to how early colonies were in the New World 300 years ago. These colonies were initially funded by and owned by a single private entity, the Virginia Company in the case of Jamestown. At this point, the base no longer looks like a base at all, but an actual lunar colony. But what keeps this growth going? What makes a colony grow beyond a village, a small town, into something bigger, more complex, more rich in life and opportunity? What makes a city? Advanced human capital. A specialized, value-added economy. A city has to offer at least one unique economic export to make its economy grow beyond simple service and subsistence. LA and New York have culture. LA has technology, and New York has finance. Austin has a mixture of both, and Detroit used to have automobiles. This is often geographic in nature, as in coastal towns offering ports and safe harbors. Luckily, the moon has a very advantageous position in its ability to export one of the most capital-intensive products much cheaper and competitively than anywhere on Earth: satellites. Forbes estimates that Starlink could be worth about $30 billion by 2025, assuming it generates about $10.4 billion in revenue by then. And if Starlink is not enough, others plan on implementing their own constellations as well. Starlink satellites are estimated to have a lifespan of roughly 5 years, which is pretty typical of small sats. Starlink filed 42,000 total satellites with the FCC to be launched over the next few decades, which is more objects than have ever been launched in history, and the others have filed similar numbers. Needless to say, Starlink and the others will need to be constantly and rapidly replenished, costing billions in launch costs. All of this is to say that in the coming decades, there is going to be a massive increase in demand for launches to low Earth orbit. This shows the velocity change required to get from one point to another for any given vehicle and is a fundamental component of the Tsiolkovsky rocket equation. Velocity change, or delta V, from the moon's surface to low Earth orbit is 6.4. Delta V from the Earth's surface to low Earth orbit is 9.3 to 10, plus the option to aerobrake if exporting to the Earth's surface. This just shows how much cheaper it is to launch from the moon to Earth than from the Earth to the moon. Just look at the size of the Apollo return module to that of the Saturn V it was launched on. Basically, everything below the capsule was used just to punch through the Earth's atmosphere. The moon has no atmosphere, and less gravity. Because most of the cost of satellites is in the actual launch to low Earth orbit itself, there will be specialized interest in moving satellite manufacturing to the lunar surface, especially once a capital base and service economy exists. Now, manufacturing may be a bit of an overstatement. Assembly is probably more accurate, as the intricate and capital-intensive components like computer systems and instrumentation will need to be produced on Earth, but these components weigh the least on a satellite, whereas the fuel tanks, hull, batteries if they have them, and solar panels are the heaviest things. Remember, rockets measure cost and mass, so shipping the lightest components to the moon where they can be assembled into the heavier components would be a value-added activity. The fuel tanks and hull are made of aluminum, which can be easily manufactured on the moon, whereas the fuel for thrusters can also be lunar-sourced if the satellites make the transition to hydrolox, which would be market-driven considering the savings involved. This is similar to modern global supply chains where auto parts are manufactured in thousands of different locations and countries depending on where it is most advantageous for each. A modern Falcon 9 rocket can launch about 60 Starlink satellites to low Earth orbit for a few $1 million. Take that same rocket and launch 5,000 pieces of satellite hardware rather than actual satellites to the moon for a small price increase and get 5,000 satellites out of it, thus significantly bringing down the launch costs. In general, the moon has a composition pretty similar to Earth's crust. That's much of the reason we think the moon was made when some smaller planets slammed into the Earth during the early days of the solar system. That means it is quite rich in materials we like to build out of, plenty of silicon and oxygen, plenty of aluminum and iron, and surprisingly rich in titanium. In addition, the moon has lots of creep. which is short for potassium, K, rare earth elements, and phosphorus, and tends to be heavy in uranium and thorium. There is a lot of discussion when it comes to mining asteroids, hypothetical dragon hoards of gold or platinum. There are many accessible asteroids, some in cislunar space with precious metals worth trillions of dollars. However, it is useful to remember that all those craters on the moon were actually formed by those precious asteroids people are talking about harvesting. And unlike on the Earth, where the atmosphere erodes the asteroid nearly completely before impact, if there is one at all, on the moon, the lack of atmosphere means that much of the asteroid's raw mass would remain in and around the crater. But asteroid mining, although unprofitable to bring said raw material back to Earth, could be profitable in towing it to the lunar surface once a growing economy has been established. This is the beginning of the expansion into cislunar space, meaning the space around and between the Earth and the moon. Similarly, there is economic potential in using the moon as a place to launch missions to Mars from, for the same reasons it is the ideal place to launch things to low Earth orbit. Basically, the moon is a giant orbiting warehouse just waiting to be colonized and turned into a launch pad for our expansion to the rest of the solar system. So what has been done so far, and what still needs to be done to make this a reality? Well, the cost of transportation has always been an issue. The average launch cost between 1980 to 2000 was $18,500 a kilogram. Since 2000, launch costs have fallen by over 86%, with Falcon Heavy at $1,400 a kilogram. And if Starship is truly $10 a kilogram, then launch costs will have fallen 99.9%. NASA predicted that by 2040, launch cost would be about $40 a kilogram using a space elevator. Obviously, they weren't taking into account reusable two-stage rockets with full flow engines. Next, a lunar outpost will need three things: water, shelter, and fire. Except on the moon, electricity is our fire. Frozen ice exists on the poles and crater pits that never receive sunlight. But recently, water was also discovered in sunlit areas. Because water will most likely be gained from ice which will need to be mined, lunar water harvesting and lunar mining go hand in hand. There is already a lot of interest here, and few problems. Essentially, this is solved, and saturated with competition. Shelter, likewise, is well established. There are multiple companies that have already demonstrated shelter construction capabilities, relying on 3D printing rovers that 3D print lunar regolith into protective shells around inflatable lunar habitats. So what about fire? Power. Electricity. Currently, there are two options: nuclear and solar. Obviously, there is no coal or hydrocarbons on the moon to burn as we do here on Earth, but there is sunlight and multitudes of reactor fuel. But there are major limitations to both. The issue with nuclear is that reactors are expensive, heavy, and are typically just heat generators used to power traditional steam turbines, which are similarly heavy. There are, however, simpler Seedbeck reactors developed for deep space missions where sunlight is weak, like the ones used on the Mars rovers. These use a chemical reaction to convert thermal energy directly into electricity, but these have much lower energy output than conventional reactors and are similarly expensive. If we are talking about powering more than a car, we need to look elsewhere. Solar's biggest problem is that solar panels, similar to nuclear reactors, are complex. What I mean by that is that in order to produce a solar panel, we need supply chains and capital investment, which we don't have on the moon. And while the ultimate goal is to eventually have that, we would still need to haul every panel to the moon aboard a rocket for a while before being able to produce them there. Not only would this be expensive, but it would also cripple growth and expansion as you would be limited by the rate of solar panel importation. As if that was not enough, solar has a special Achilles heel on the moon, and that the lunar night lasts 14 Earth days. So, we have largely solved all the issues except electricity. We have the vehicles to get us there, the type of culture and societies interested enough to create a demand for it, technology and tools to construct it, and the ability to supply it. But there is a second issue which needs to be addressed. This one is not a technical issue, but an economic one. The solution to which is not in better rocket engines, but in simple, good old-fashioned infrastructure. As it stands, anything exported will need to be launched from the lunar surface back to Earth using a rocket that was built on Earth, as building rockets on the moon is, for the foreseeable future, unlikely. Rockets are hard enough to build on the Earth and are capital intensive, so they will need a very sophisticated economy before they can be made on the moon, if at all. This means that anything exported will need to rely on reserving payload space aboard rockets that are there for other reasons, such as dropping off supplies and researchers. This means that rockets returning will have most of their payload space taken up by the people and their life support systems and research samples, etc. If an empty rocket were to be contracted to go to the moon with the sole purpose of returning full of trinkets and gift drops, the items would cost as much as it does to get to the moon's surface and back, which would result in moon mugs costing thousands of dollars. This is not ideal, and would not result in a climate hospitable for economic growth. This problem is saturated with opportunity. Fundamental to success is the ability to launch from the moon's surface without rockets made on Earth. One of the first engineering descriptions of an electric gun appears in the technical supplement of the 1937 science fiction novel 0 to 80 by Akkad Pseudoman, a pen name for the Princeton physicist and electrical entrepreneur Edwin Fitch Northrop. Yes, the guy who co-founded Northrop Grumman. Dr. Northrop built prototype coil guns powered by kilohertz frequency 3-phase electrical generators, and the book contains photographs of some of these prototypes. The book describes a fictional circumnavigation of the moon by a two-person vehicle launched by a Northrop electric gun. Basically, it is a giant coil gun that accelerates objects fast enough with electromagnets so that they reach orbital velocity using electricity only, no fuel necessary. The concept was called a mass driver and was proven to be super impractical on Earth because the gravity is too strong, so much so that a track would need to be about 3,000 kilometers long, which is the distance from New York City to the Rocky Mountains. Not to mention, it would also need to be vacuum sealed because we have an atmosphere. Because of the low gravity and lack of atmosphere on the moon, this needs be no more complex than just a railroad track on the moon, and modern maglev trains have already thoroughly paved the way for such a thing to be constructed. But the biggest issue with the mass driver is that, like modern maglev trains, it requires a massive amount of electricity, and as we already discussed, this is somewhat of a large constraint on the moon. So those are the two biggest issues we currently face when it comes to colonizing the moon: electricity and the ability to construct electricity-dependent infrastructure that would feed the lunar economic expansion and growth. Hopefully these issues are solved sooner rather than later, as our time on this fragile and volatile pale blue dot is limited and could end any moment. Tourism will lead the way, but there needs to be a larger economic motivation to sustain our outward growth and expansion, so satellite exportation to low Earth orbit will follow suit. I predict that, as humans adapt to this new situation, there will be even more opportunities not currently considered, as is always the case when we push the frontier. The sooner we expand consciousness beyond Earth, the better chance it has at surviving in this hostile and unforgiving universe.